All right, so today we are looking at our next type of family, and we're going to start by looking at this example with Monica. And we are looking at so she's in a hot air balloon and she's used a GPS device to measure distance from the top of Mount Franklin and also the height of the balloon. And you can see I've gone ahead and I have graphed the points that are in the table, and I have a pretty good picture of my graph here. So the first thing that you're being asked is this relationship linear? Why or why not? And just by looking at the graph, I can tell that this relationship is not linear because the graph is not a line, it's a curve. Okay, so that is how I'm going to answer that first question. I'm going to say no, the graph is not a line. Okay, and if you're ever asked about that, the answer is in the word linear. You should have a line. Linear is a line, not a curve. Okay, all right. Next question is asking us to find the first differences, which is just the change in y. Okay, and we're going to go ahead and do that just like we normally would if we were looking at any table. But I want to pay close attention to the fact that all of our x's, so our change in x is constant, and we're adding 10 all the way down. So we have a constant change in x, and now I'm going to analyze my change in y. Okay, so I'm just going to use orange to notate this, and this is also known as the first difference, okay, because we're finding the difference between these numbers. Okay, so if I go from 8 to 32, I'm thinking about that, and I'm thinking to myself, okay, what am I adding to 8 to get 32? Okay, and we are adding 24. And then I'm going to continue. 32 plus 40 is 72. 72 plus 56 is 128. 128 plus 72 is 200. 200 plus 88 is 288. And 288 plus 104 is 392. Okay, so we've done the first differences, and then we're asked, do you see a pattern? So we are used to seeing that first difference be the same number, right? Because we're used to dealing with a linear relationship. So whenever we have a constant change in x, we have a constant change in y. That's not the case with this, and that's because this is not a linear function. Okay, so we're going to go ahead and answer that there's not a pattern. Okay, so we're going to explore further. Okay, so we've identified from the graph that this is not linear. We've identified from the table that this is not linear because we don't have a constant rate. Okay, so now we're going to explore a little further, and we're going to find the second differences. Okay, and this is new, but the second differences mean we're just going to repeat what we did with the table with the orange set of numbers. So we're just going to do that again. So it's the difference between the first differences. So here's my second difference. I'm going to use yellow for that. Okay, and I'm looking between all of these numbers now and seeing what the change is, because I know it's not linear, so I need to explore a little further. Okay, so I'm looking from 8 to 32, and I'm thinking to myself, okay, or not 8 to 32, I'm sorry, 24 to 40. I'm saying, okay, well, 24 plus 16 is 40. What am I doing to 40 to get to 56? Well, 40 plus 16 is 56. 56 plus 16 is 72. 72 plus 16 is 88, and 88 plus 16 is 104. Okay, so clearly there's a pattern there, right? We have 16 all the way down. So do we see a pattern? Yes. And I'm going to say we have a constant second difference of 16. Okay. All right. And whenever we're analyzing a table and we have a constant second difference, that is also an indicator of this family. Okay. So common second difference identifies a quadratic function. And we're going to look at two more examples just to give a better picture of the graph, because this first graph is just a snapshot, so it doesn't give you a full picture. Okay, so let's take a look at the second one. And I've gone ahead and already plotted these points. Okay, so you can see the graph. Graph is not linear. We're going to write this on your vocab, but I'm going to write it here as well. This is called a parabola. And parabolas come in smiles and frowns. Okay, this is obviously a smile, but they can also come in frowns. And then if we look at our first example, that's half of a smile. So we have a piece of the graph. Okay, but we have enough to say here that no, it's not linear. The graph is not a line. Okay. Part B asks us to go through and find the first and second differences. So I'm going to do the same thing that I did in the table above, and I'm going to color code again. Paying close attention to the fact that our change in x is constant. Okay, it's +1 all the way down. So now I'm going to look at my first difference. Okay, so from 17 to 10, I'm subtracting 7. 10 to 5, subtracting 5. 5 to 2, subtracting 3. Then subtracting 1. And now I kind of change directions here. From 1 to 2, I'm adding 1. 2 to 5, I'm adding 3. 5 to 10, adding 5. And 10 to 17, adding 7. Okay, so no common first difference, which means it's not linear. We're going to look at the second difference. -7 plus 2 is -5. -5 plus 2 is -3. Plus 2 is -1. Plus 2 is 1. Plus 2 is 3. Plus 2 is 5. Plus 2 is 7. Okay, so we have a constant second difference. So there is a pattern. There's a constant second difference. Of 2. Okay. All right, we are going to look at one more set of data just so that you can see what it looks like to have a frown. Okay, so I'm going to look at the second one. And I've gone ahead and plotted the points and connected them, and I have a frown. So this is a parabola as well, but it's a frown, so it's an upside down parabola. Indicates that it's quadratic, so we can say that it is not linear, because the graph is not a line. Okay, and then we're going to go through again with the first and the second differences. Noticing that our change in x is constant and it's +1. And I'm just going to go through. Okay, so -7 to -2, I'm adding 5. -2 to 1, adding 3. Adding 1. Subtracting 1. Subtracting 3. Subtracting 5. Subtracting 7, subtracting 9. I'm going to examine further by checking my second difference. Okay, from 5 to 3, that's a -2. 3 to 1 is -2. 1 to -1 is -2. -1 to -3 is -2, and you can see that that pattern continues, -2 all the way down. So do you see a pattern? Yes. there is a constant second difference. Of -2. Okay, and you're done. In vocabulary, I posted, we talk about, I show that what the equations look like. Okay, so the equations look like they have x, they have the variable x, and they have the highest power of 2. So you would have a squared term. You would have x squared, and that would be the largest power that you would see on x. Your graph would be a smile or a frown. It would be a parabola or maybe a section of a parabola. And if you were looking at the table, you would have a constant second difference.